Hi, this is Stephen Brower from Irvine Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is the overview for Irvine Chapter 11, which is on the Windows API. So the earlier part of the book goes through sort of an overview of what the API is in and of itself. And there's a series of sort of functions that are available to be used, and they're in these dynamic linked libraries. Dynamic linked libraries, once they're loaded into memory, will remain in. So when a program closes, the dynamic linked library will still remain behind. Two of the ones that are mentioned are the kernel 32 and the user 32 DLL, and those are in the Windows System 32 folders. So what those DLLs are is sort of a series of routines that that we can call. The software development kit is sort of like an extension of that, so that we can use Windows. So it's a collection of tools and libraries that helps us create applications in the Windows environment. And so one of the other demos that I have, I go through, there's a demo that's on this, and one of the key things in there is the idea of handles. And there's a handle for every object that the operating system is managing. So getting input from the keyboard, there's a handle for the keyboard. The console, there's a handle for the console. If you're dealing with a file, there's a handle to the file as well. And so what's happening here is we're getting the handle for the output console, getting the handle for the input, getting the input handle, and here we're writing to the console, reading from the console. Here we're creating a file, writing to the file, closing the file. And handles, and just sort of a reminder, if you bring up Task Manager, one of the items in there is handles. And at the time I did the snapshot of my computer when it was running, I had at that point 89,109 handles. And so for the program that was running, for the demo, for the program that's running, it uses one handle is representing the keyboard, the other handle is representing the console that comes up on the screen, the outputs part, and another handle to the file that's on the computer. So the handle approach for dealing with dealing with objects is something that's sort of introduced there, and it's that once we have the handle, we're referring to it after then by the handle. So meaning like for the output console, the calling of this routine, EAX has the output handle. Well, later when we write, we have to use the output handle. Getting the standard handle here of the input, we store that into input handle, and then later when we're reading from the keyboard, we use the handle. Here on creating the file, EAX has the file handle, and later when we write to the file, we write using the file handle, and we close the file using the file handle. So the handles are something that is introduced as one of the demos. One of the other things that, let me draw attention to this. So in the root of the hard drive, we have the Irvine folder. Inside the Irvine folder, there's the Irvine 32 Inc., and we have been including the Irvine 32 Inc. Well, the Irvine 32 Inc. actually has some include files in it. One of the include files it has is this small win.inc. Inside the small win.inc are a series of structures which are reviewed in Chapter 10, and one structure has to do with a coordinate. And when we're talking about the screen, then it would represent the row and the column where that what's going on to the screen would be. And then if we're dealing with what is the current date, time, we actually have a structure that would be for the system time. And when you're dealing with the operating system, what you really have to do is you have to give it a handle to one of those structures in memory. So in other words, we actually have to set aside memory with so many fields. Here this is 2 words, and here it's 1, 2, 3, 4, 5, 6, 7, 8 words. So you have to hold aside, if you have a coordinate, 2 words held aside. If you have the system time, 8 words held aside. And then when you're dealing with the operating system, what you'll pass it is the address of that instance of the structure that's going to be holding information. And the operating system, in some cases, will pop or push information back to where we have. So if we're asking the operating system for the time, we'll set up a structure, we'll send the operating system the address of the structure, and then the operating system will poke into these fields the values for what the current date time is. Now that one specifically on the time, I don't recall off the top of my head whether that's one of the demos I have loaded in, but it definitely is one of the demos that's in the author's library. So when you look in the Irvine folder and you see the Chapter 11 folder, one of the Chapter 11 ones there has to do with like the timer. Another thing that's covered in Chapter 11 is referring to how memory is managed with applications that are running. What I haven't necessarily been doing correctly up to this point, the data segment that we have in the programs that we've been using, the .data part, that actually is saved into the executable file. And so the more data you declare, when that program is loaded in, what's also loaded in is the initial set of data that is in the data segment. But the way something like Java works, if we're trying to allocate an array, it really does that dynamically. And so what's introduced in Chapter 11 is the idea of basically asking the operating system for a chunk of memory, which is coming from the heap, and then it's up to us to manage that pile of memory that we have. And so what Java would do is that if you're allocating an array, it asks of the operating system, well, I need this many bytes to handle that array. And depending on what it's an array of, will be how many bytes that it's going to need to ask for. And then the operating system hopefully grants that. And then what the application will have is the pointer to where this pile of memory is. And then it's up to the program to manage it. So one of the demos I have, I'm actually going to be creating, and actually I do it as user input. So I actually have 250 million, roughly, integers that I want to create, and at 4 bytes each, that's a gig. And so what you see when that program is running is, looking at the task manager, we actually see that that application, when it grabs it, is then getting a gig of memory from the operating system. And then the key thing that it does is it releases it. And that's some of the things old programs in the past had, is that if they didn't release memory, then they had what was known as a memory leak, meaning an application would start, and then when the application closed, that memory was still being held. Then you start the application, it grabs another chunk of memory, and then you close, it was still being held. So memory leaks where the memory that was allocated wasn't freed up. But we'll see in that demo the allocation of memory from the heap, the use of it, and then the freeing up of what we have. This overview here really is just the tip of the iceberg, but that's what we're seeing in Irvine Chapter 11.